first thing that we want to solve for asks us what is the speed of the chain at this instant. The instant being us pulling until we make it reach a distance of 3.4 meters. Alright, so first we define our system. Just include everything here, the chain, hand, and earth. It includes all the forces. Alright, and so we have our basic fundamental principle for work energy is that the change in energy equals work. So we know that E2 minus E1 is going to be the work. Well, we know that E1 is 0 because it has no kinetic energy while it's just sitting still in this ball. So all of it is going to come from E2. Alright, and E2 equals 1/2 mv squared. That's the kinetic energy. Alright, so that's what the work is equal to. We're going to relate the kinetic energy to the other definition of work, which is force dot product delta R, and we're going to relate those to each other, and we're going to get it down to velocity equals the square root of 2f times delta Rx over m. And now all we need to figure out is what is our delta Rx. So we're dealing with a point particle system here. So it's the amount that it moves. We're looking for the amount that the center of mass moves, not the end of the chain. The center of mass is only going to move d, the total distance, minus 1/2 L. And the center of mass right here, that's how far it's going to move. So we could simply calculate that by subtracting 1/2 L from the total distance, which is d, and we get 2.9 meters. So we plug that in. We have our force given. We have our delta R of x now, and we have our m. And we plug all that in, and that lets us solve that velocity equals 8 meters per second. Alright. Next, we have our system, is the chain, hand, and earth. And what we're solving is we're looking for the change in energy, and we're considering this a real system. Okay, so to find the total change in energy of the system, we know that that definition is the E translational plus E thermal. There's no other types of energy present in this equation, so those are the only two. So we know that's our energy total, and we know that it is I'm sorry, I'm getting ahead of myself. I was looking at the wrong one. Okay, so work equals delta E, and we're still going to be able to define that as the force times the delta Rx. And this time we're dealing with a real system, so our delta Rx is going to be different than it was in the previous one. The real system is how much that the point that the end of the chain is moved, and we know that it moves a total distance of d, which is 3.4. So instead of using the 2.9 in the last equation because we're looking at the center of mass, now we're looking at the total amount that it traveled, which is 3.4. So that gives us our delta Rx, and then we just multiply that by force, we get 187 joules. So now, last one, we have the joules. 187 joules is equal to the thermal plus the translational. We know that translational is 1/2 mv squared, so we're just going to plug in for delta Rx, and we already have our force. We get 160 joules. Subtract that from the total, and we get our delta E thermal, which is 27 joules.